In summary, for the nth root of a, the equation nth root of a equals b means that b to the power n is a, where n is a natural number we call the index, and a is the radicand. If n is odd, we're finding an odd root. If n is even, we're finding an even root. If a is positive, then the nth root of a is a positive number. If the expression under the radical contains a variable and we're working with an even root, we're going to use those absolute value brackets. If a is less than 0, if a is negative, and n is odd, then the nth root will be a negative number. But if n is even, then the nth root of a is said to be not a real number. We can look at radicals in terms of functions. We've seen these graphs before, back in chapter 16 when we talked about function families. These are the graphs of our root functions, our radical functions. Take a moment and recall, what is the domain of even root functions and the range? What is the domain of odd root functions and the range? And why are they not the same? Pause the video and write these answers down on your own, and then when you resume, we'll check. Even root functions are our square and fourth roots, and we see that we only have values graphed in our first quadrants. Our domain is 0 to infinity, and our range is 0 to infinity. For odd root functions, this is the cube root and the fifth root, and we have values for all of our x's, and we have values for all of our y's. These graphs just extend further and further on. It doesn't look like they're climbing very far, but if we go far enough out, we will obtain all of our y values. So our domain for odd root functions is all real numbers. Our range is all real numbers. Why are they not the same? Mostly coming down to even roots. I cannot take an even root of a negative number, so that restricts my domain for our even root functions. By restricting the domain, we also get a restriction in the range. Our odd root functions don't have such restrictions. That's essentially the difference. I'm going to let you write that in your own words. So let's continue to practice what we learned from chapter 16 in functions, talking about finding the domain. Here we have three radical functions. They are all square roots, even root functions. And we want to find the domain in interval notation and then use the domain to match the radical function with its graph. In all of these cases, the radical function has been transformed. We don't just have square root x, but now we're moving the function to a different location, left, right, up, or down. And we're also multiplying the input x, at least in the last two, by a number, which causes the graph to expand or contract. It's not the same shape. It gets a little bit bigger or a little smaller, depending on the situation. So let's take a look at the first one. If we're finding the domain for an even radical function, we're going to focus on the inside. And remember, all of these are even radical functions. Since they're even, our domain is restricted. Whatever's underneath the radical, set it greater than or equal to 0, solve for x. We get x is greater than or equal to 3, or 3 to infinity. If I'm looking at this first graph, 3 to infinity does not match up to where the graph is. The graph is 3 and down to negative infinity, so that doesn't work. 3 to infinity is shown in this graph. And this one starts at -5, so I know this last one's not correct. The first function matches up with the second graph. For 12, underneath the radical, 3x plus 15 greater than or equal to 0. Solve for x. 3x is greater than or equal to -15. Divide by 3, we get x is greater than or equal to -5. So we have -5 to infinity, greater than. Looking at my remainings, this function here starts at 3 and goes to negative infinity, so the first one's not right. But the last one starts at -5 going to infinity, so the second function will match with my third graph. Well, that does mean that our last function is going to match with our first graph, but I want you to take the time and see if you can find the domain. So pause the video and find the domain for our function h of x and see that it matches our domain here, which would be negative infinity to 3. And sure enough, it does. Now, what is the domain of f of x equals the cube root of x minus 5? Since it's a cube root, an odd root, all of our odd radical functions have a domain of all real numbers. What would the graph of the square root of x plus 5 look like? What about cube root of x plus 5? Draw a graph. Take a moment, pause that video, see if you can sketch a quick graph of each of these. So for the square root of x plus 5, that plus 5 on the end means we're translating it up 5. 1, 2, 3, 4, 5. Our original square root x function looks like this dotted function somewhat. So I move it up 5 and I'll get that same shape, just starting at y equals 5 instead. For the cube root of x plus 5, it normally starts at 0, 0. We've got a nice little curve going on here, and it's a very shallow curve because when x equals 8, y equals 2. So we have to get all the way out to 8 before we climb up to 2. So add 5 here, it's the same thing. 1, 2, 3, 4, goes up 5, and a nice little curve going through. So cube root x plus 5 versus square root x plus 5. That plus 5 just adding up. Shift upward by 5. How about for 16? The plus 5 underneath shifts the graph left 5. Remember that the plus in with the x goes in the opposite direction. This is a left 5 shift. Draw a graph for these. If you need to check out that OneNote. In problem number 17, we want to bring into this chapter our discussion on functions and function transformations. So here, if we had the square root of x, what would happen to that function if we, for example, add 2 to the end or subtracted 5? Or what would happen if we subtracted 3 inside or added 4 inside? I'd like for you to take a moment, pause the video, and try this out on your own. And when you resume, I'll have the answers for you. Make sure to pause, try it out, and then check. Adding or subtracting on the outside is a vertical translation. So adding makes us go up, subtracting makes us go down. For adding or subtracting underneath that radical with the x, this is a horizontal translation. Subtracting inside means we go right, adding inside means we go left. Remember that horizontal translations work in the opposite direction we think they need to. We need to trick the function into giving us the same y value as it was before we moved it. In problem number 18, find the domain without graphing. Here it's important to really pay attention to what type of radical you have, if it's an even radical or an odd radical. So looking at the first one, square root x plus 2, there's no index indicated. This is an even radical, which means we have a restricted domain. We'll take everything underneath that radical, x minus 2, and set it greater than or equal to 0, and solve for x. So x is greater than or equal to 2, greater than 2, that's 2 to infinity, and we'll include the 2 because of the equal sign. Looking at the next one, the index is 4. This is another even radical, so the inside greater than or equal to 0. Solve for x. I'll give you a moment to do that one on your own. How about for g? What is the domain for g? Our index is a 3. This is odd. Odd radicals always have a domain of all real numbers. We don't have to worry about setting the underneath greater than or equal to 0. We have no restrictions on our odd radical functions. How about for h? Oh, 6 is another even one. Set the inside greater than or equal to 0. Solve for x. Here we could add x to both sides or subtract 9. It doesn't matter. Just remember, if you subtract 9, you've got to get back to positive x. When you divide by that, it's going to flip your sign. So 9 is greater than or equal to x, or if we rearrange it, x is less than or equal to 9. Notice that my crocodile is eating the 9 in both cases. That's how I remember greater than, less than. And so then we can write x is less than or equal to 9. 9 is the biggest, which means we're going down to negative infinity. Did you figure out the second one yet? Right, x is greater than or equal to negative 3/2. Negative 3/2 to infinity. In the last part of this lesson on radical functions and expressions, we'll talk about applications.